Alright, we're back again for a tutorial session, and I've just done this already, but I realized there's a small bug in Glitter, and so I had to restart. And then I realized there was a way around it. So we're gonna do the way around things. Anyway, let's get back to what we did last time. So last time we introduced variables, and variables have a type, and you don't have to say the type. You can either say that's an any, or you can use let. I think you can use let. I keep forgetting. I think it's var. What does that do? That wasn't valid in this context. What have I done wrong this time? Oh, that's right. Var, that will infer the type. I don't think I should have changed this. All right, we'll just stick with this. So we're going to stick with putting the type in there for now. So you declare variables by typing the type name, the variable name, and its initial default value. And down here we can change code, we can change variables, and we can do this kind of complicated expressions that refer back to themselves. So we're going to write some new code. That was the code from last time. I'm going to quickly go through this. I think the last video was better, but we'll just have to go with this. So the first thing we're going to do is we're going to go int total equals 0. And we're going to go back to our old friend, the repeat loop. Repeat 4. And then we're going to say total equals total plus 1. So reminder, don't get too confused by this code, because it's not algebra. You've got a total on one side and you've got total on the other side. And the way to remember this is this side of the thing is worked out first. So when we start off, we're going to put in here total equals 0. And then we're going to say total equals total plus 1. So what does that mean? It means first we read the value of total. So the first time we come in here, it will be 0. And then we're going to add 1. And once we've got that value of 1, we no longer care about the value of total. Total can change, doesn't matter. We're storing in the computer's going, I've got the number of 1, and now I have to stick it into this variable total. So then the computer's chucking it into total. Remember, variables are little boxes. And the reason we have types is that it helps the computer to know what size box to make and how to put things in and out of that box. Alright, so we do this, and then we come down here and we print total as total. So if we compile and run that with Control F9, you can see in small text, yes, I was going to change this code so that you can change the font here, and that will be in the next version of this tool. You can see that the total is 4. So sprite 0 is saying the total is 4. We might change the name of sprite 0 while we are here. We'll click on that. We're going to call it tutorial. All right. And then when we run it, tutorial total 4. Okay, so we've got the right thing. That's all fine. First thing of usefulness is that we can rewrite this, since it's such a common piece of code, to look like this. Total plus equals 1. So these two lines of code, this line here and this line here, are equivalent. This basically means increase total by 1, and this explicitly says increase total by 1. And if you export this out to Scratch, this comes across as the built-in Scratch function of increasing a variable by 1. So that's a standard thing in Scratch. And that's what it gets translated to. So this is a one-to-one correspondence with the increased variable by function. You can also do total minus equals 1. That will decrease total by 1. And again, this can be whatever expression you want. If you put total there, then that will just that's the same thing as saying 0. That's a fancy way of saying make total be 0. In other languages, you can do multiplication and division. You can't do that in Glitter yet, but you will be able to one day. So we go plus equals 1. And then if we compile and run that, you'll see that total now equals 8. Because we're doing the increase twice. So each time through the loop. Sorry, I have to have a drink. Each time through the loop, we're increasing total by 1. So we're going to go through what's happening. We're going to get rid of that one for now. I'll explain why in a second, that I didn't get rid of this piece of code, even though they are exactly the same. We will talk about it. First off, we set total to be 0. And it's good form to just reset the value each time, unless you're only using something once for some reason. In future, I'm going to get rid of the need to put in a default value, but currently you need to give an initial value for all variables. So down here, we set the total equal to 0. So we come into the loop. The first time we go into the loop, total will be 0. So this will add up to 1, and then total will become 1. And then we'll come back down here, and we've still got to do this 3 more times. We'll come back in here, total will be 1, and then we're going to add 1. So this thing evaluates to 2. So the expression, we say evaluates to 2, and then we store 2 in total. And again, we do this several more times, and at the end of it, total is 4, because we went through the loop 4 times. Now we're going to learn a new function. It's going to be an exciting function. We're going to call it, we're not going to call it, this is what it is called, randomInt. And you can't seem to find it in the list of helpful things in release version 3 at least, because this is what currently this is effectively. But in version 4 it will be in here, probably under operations. I forgot to add it in through the list of operations. If you look in here, I don't think there's any function listed in there. But how does it work? Well, I'm going to tell you how it works. The first, it takes 2 parameters, 2 arguments, 2 input values, whatever you want to call them. The first value is the lowest number, so we'll say 1 in this case. And then the next value is the highest number inclusive. So this is going to, actually what we will do is we will go int value equals 0 with a semicolon. If you want to get into Java programming, put the semicolons on the end of the thing. There will be a version of this where you can specify to tell it off, to make it so that it tells you off if you don't put a semicolon at the end of the line, but it isn't there yet. Just so that you can get good at C and Java coding, because they all require the semicolon in places. What we're going to do is we're going to go value equals, and we're going to take this, and we're going to put it into value, and then we're going to go total plus value. Alright, but we're also going to print out what the value was, and the value is and then we're going to run it. What did I do wrong? Value equals hold on, what? Unknown token. Have I discovered an error where I've put my I think. Nope. Oh, I can see what the problem is. Okay, here we go. It's not my semicolons. It is. I probably should have read this. So we'll use this. So sometimes error messages are not always that helpful, but if you pay close attention, they might be helpful. So it says unknown token value. So we go here, and it thinks that this is a token. And if you look very carefully, it's actually the string. So this whole thing it thinks is like something to tell. It doesn't understand that this is a string and then a variable over here. And the reason for that is, so if you look at this and you say, it doesn't understand what this means, and you're like, well, it should understand what this means. It means what the problem here in this case is that this is not a double quote, it's a single quote. So it got confused. It doesn't know that this is a string because you didn't finish the double quote at the end of the string. And the string is just a piece of text. It's what they call text in computer world. All right. Well, they also call it text, but this thing is a string. Okay, so now it should work. All right, so we come here and we can see that there's a whole bunch of values, and then we've got 2 and a 5, 2 and a 2, and they end up to 11. If we click on the flag again, we've got a 6, a 3, a 3, and a 1, and they add up to 13. And then we have a 3, 3, 3, 3, 2. These don't seem as random as I would hope, to be honest. Well, that looks like you can never really tell. That's the thing with human psychology. We don't really understand. I mean, computers don't make random numbers, but honestly, you can't get 5 5s in a row. There's a lot of triples in this. This one looks nice. 4, 5, 3, and 2, and they add up to 14. Okay, all right. Maybe we'll try and work on the random number randomness. Or I'll do a tutorial where we write a tool to analyze the random number values and to see if they are truly random. But anyway, for now, we'll assume they are. And so we've printed them out. So basically, we're getting a different total each time because we're adding a random number each time to the loop. But we're only doing this 4 times, like we always have been. 4 times here. So we're going to learn about a new kind of loop. What I really want to do is I don't want to know what the total is after so pretend this is rolling a dice or a die. So a dice gives a number between 1 and 6. A die gives a value between, I keep forgetting, between 1 and 6. And so then we're adding them together. But I want to know how many times would it take. Well, you know, I want to roll some dice, and I just more interested in the number of times it took me to get a total of 30 or more. All right, so I don't care about the total exactly. I just care about how many times I had to roll that dice to get a total of 30. So we're going to have a new variable. It's going to be a fun variable. It's going to be called count, and I'm not going to misspell it. All right, so count, and we're going to start off with count equals 0. And then we are going to go count equals count plus 1. I will briefly talk about why I'm writing it out the long way. And then down here, we're going to print out the count. So we'll do our first step, which does nothing interesting. It's always going to say 4. This is getting a bit, we'll go down here. So the count is always 4 because we always do the loop 4 times. So every time we go through this loop, we increase the count variable by 1. So the reason I'm not going plus equals, though you can do that, plus equals count, plus equals 1, that should still work. It does still work. But if I forget this line, in the current version of Glitter, it will do this. It will say, cannot be assigned values, not a useful message. This is a feature that will not be apparent in future versions of Glitter. This error. It's got a lot to do. I'm just going to quickly explain it and then completely ignore it for the rest of the video. It's got something to do with the way this language is interpreted and understood, and how variables are used and created. And it's very complicated to explain here, but there's a bug in the plus equals that I didn't realize, that it's not promoting, I'm going to use this word, this count variable to be what I would call an app variable. And just briefly, I will try and explain. So if I go int max value equals 6, and then I change that to max value, if I was to export this out to Scratch, you would never see a max value variable. You would only see the value 6 in this function. When you looked up the code in Scratch, it would say 1 to 6. There would be no max value. And this is because the compiler has worked out you never change max value. It's not changed within the code, so there's no point making it into an actual variable. And it just stores the value, the fixed value of max. You can change it, of course, down here. You could go max value equals 7. It doesn't matter. It's just gonna say that's 7 this time. And it's a complicated language feature that has nothing to do with the basic tutorials. Just all you have to be aware is in release 1, 2, and 3, there is a bug in plus equals that does not properly convert that to be a real variable at runtime. So we'll just get rid of that. So that's why I didn't write that, and that's why I'm not doing it in this tutorial. So from now on, forget all that I said because it's way too complicated for a beginner. Now, we'll come down here. As long as I have this count equals 0 up here though, everything is fine. This count equals 0 is promoting it to be an app variable. And an app variable can be changed when you click on the flag because it's the code. So anyway, we'll come down here. Now we want to find out how many times we have to do this before we reach a total of 30. So we want to do this loop while the total is less than 30. And so I just said this in plain English. And in fact, that's pretty much how you would type it out, but with, slight differences to get the next kind of loop. So we're going to say while the total is less than 30. So things to know, this here is what we call the conditional, and it is something that is either true or false. And we have here a little symbol. It is a triangle bracket if you want to look at it that way, or it is the less than symbol. And that basically means what it says, while this total is less than 30. If you get confused, just remember the alligator eats the larger number. So this is true if 30 is larger than total, because that means the alligator is eating the right thing. If total was 40, the alligator would be eating the wrong thing, so this would be false. So you're saying, is this true or false? And the answer is, when we first come into this loop, when we get down to this line, total is 0. So total equals 0, and 0 is less than 30. So this would be true. So every single time we come to here, we do this bit of code, and then we come back up to the here. So it will do this block of code over and over and over again as long as this is true. And as soon as this is no longer true, then it moves on to the next command. Right, so we will now see what happens when we compile and run it. So you can see that it's doing it now. It took it 10 times. We might actually want to, we're going to change this to status, and we'll go total, and we'll spell it correctly. So as you can see, it starts off and it goes, the first number it gets is a 6, so the total is 6. The next number it gets is a 4, the total is 10. The next number is 14, 16, 19, 20, 23, 29, and then finally we get to 33, and then we no longer do the loop because the total, 33, when we say 33 less than 30, that is false. So we no longer do the loop. And so the answer is we got a total of 33, and we had to go through the loop 9 times. If we run it again, still 9 times. This time it took 8 times, so we're down to 8. We got an 11 times. That was a terrible run. And we've got 10 and 9 and stuff like that. So we have this while loop, which is quite interesting, right? So this is not in Scratch. Scratch does it the other way around. And in fact, you can also do it the other way around. So first of all, look at this. What's this little less than symbol? Are there other versions of this? Yes, there is. You might be able to guess that it's greater than. Sorry if I can type. Greater than. So if total is greater than 30, because the alligator is eating that. If you want to do less than or equals to, it's less than or equals to. Less than or equals. And greater than or equals. So we haven't quite got to how do you compare two things to see if they are equal. We will do that soon. But if you want, there's another kind of loop that is basically exactly the same but the opposite way around. And in Glitter you write that repeat until. So repeat until total is greater than or equal to 30. So in this case here, we will do this loop every single time until this thing is true. Right, so as long as it's false, we will do the loop. And when it's true, we will stop doing the loop. This is not a standard language feature, but this is what Scratch has. Scratch has repeat until, not while loops. So basically what will happen is this will get exported out exactly as Scratch code. And if you do a while loop, it will attempt to switch these things around. So it will probably convert, I can't remember, it depends how smart it is today, feeling today. It will convert this to while the total is great. It will convert the while loop to repeat until total is greater than or equal to 30 for you. But so that's your first interesting loop, and the opposite is just repeat until. But you will almost certainly only use while loops, and most other languages just have a while loop. And now we have one more thing which we will talk about, which is a very similar kind of function. What if you don't want to do a loop over and over and over again while something is true? What if you just want to do something if something is true, and that's just it? You're going to say, well, if this is true, do this bit of code. Otherwise, we're not going to do this bit of code. All right. So we're going to say down here, if the total, we'll do it at the bottom. We have our new command. Our new command is if. It's not randomInt. If total, right, if count, we'll do count. If count is less than 9, because that seems a bit hard, we're going to print yay. So we have a new thing that looks looks very similar to how a while loop looks, but instead of saying while, we just say if. So we say if the count is less than 9, we print yay. So now when we compile and run, our count was 9. That's not good. We'll do it again. The count is 9. Not so good. 11. Terrible, terrible. Yay, we got a count of 7. So now we print yay. Okay. So when we come down here, the count was 7 on that particular run. And so what happens is it prints out yay. But when it was 9 and 10 and 11 and all that, that wasn't true. So it doesn't do this command. And there's a slight adjustment to the if statement. Say you want to do one thing if something is true and something else if it's not true or if it's false. You could then use the else part. Now else has to go after the if statement. So it has to go after this bit here. So if round bracket conditional, the thing that it's testing, curly bracket and curly bracket. You can get away without using curly brackets, but it's terribly poor form, and I'm not going to explain how to do it. But then we have, after the curly bracket, we have else, and then a curly bracket and another curly bracket, and this time we're going to print nay. All right. So we have if else. If this is true, do this. Else, because it's not true, do this. Right? So we will take a look at that and we will see what happens. We will run it. And again, there's not enough room on the screen. We come down here. It says, yay, because we have a count of 8. We do it again. And we got, yay, because the count is 8. Do it again. 8 is always 8. And we got 12, and this time it says nay. Not so good. Now, last thing for this tutorial, what if we don't care if it's less than 9? We don't care if it's greater than 9. We only care if it's exactly 9. And this is one of the biggest contentions between programming languages, is how do you define this and how do you say this in your programming languages? So a lot of languages just they don't write equals to assign. This is an assignment statement. You're assigning the value of 0 to this variable. So some programming languages might use like a colon equals because they want to keep the equals for safekeeping. But languages like C and JavaScript and Java, which is what I'm kind of like setting this up to teach you, they don't write it like that. They write it with an equal sign. And so then you get down to here, you have this problem. It's like, well, do I just write if count equals 9? Because you might think, oh, well, you just write equals. I'm going to guess here, and you just write equals. The problem is, this statement equals, this statement means assign the value of 9 to count. And quickly, in Java and other languages, if you do that, this is a valid, syntactically, this is a valid statement. because when you assign something, assigning things is an expression that happens to return the value you assign. So this would equal 9 when you do it. It's very hard to explain without going through it. It's not. I'm just going to give some background information here. You can completely ignore what I'm saying. When we do booleans are things that are true or false. The problem will become more apparent. But either way, this does not give a true or false value here. So languages like C and Java and lots of other languages, they differentiate a comparison from an assignment. So in an assignment, we use equals because that's just what they do. And I prefer this shorter. You're going to type that more often than you type anything else. So keep that short, right? And if you want to do a comparison equals, it's a double equal sign. Some languages, like JavaScript, have a triple equal sign as well, but we will ignore that because there's no triple equals at the moment in this thing. That's way complicated stuff to explain. But basically, if you want to do an equals, it is two equal signs together. If you want to compare things to be equal, an equality test, it's two equals together. So you can remember the less than or equal to thing. So that's 2 characters long. So the equals is just going to be the same length. Just put another equal sign there. And so this thing says if count equals 9, print yay and print nay. Okay. So if we run it and we get a count of 11, we go count of 10, count of 12, count of 9, and we finally get a yay. And hopefully we can get an 8. Can we get an 8? 10, 9, 9, gosh, 8. So 8 is also a nay, and 10 was also a nay, but exactly 9 is a yay. And you have to be careful. You almost certainly should never use an equals equal sign. You should never do an equality comparison in a while loop. It's probably a bad sign, but you often use them in an if statement. The problem is if I went equals equals, quite often it will not equal, the total will not be 30. It will either be less than 30, and then once it reaches 30, it will probably be over 30. And what will happen is this horrible mess. Hold on. Wait. Repeat until. We do probably have time for one last little thing actually. Repeat until the total equals 30. So we do that, you'll see that it just goes on and on forever because we got past 30 and we'll keep going because it will never go back down again to 30. So it's just going to continue. We didn't hit exactly 30. So my advice, if you're typing an equals equals into a while loop or a repeat until loop, you probably are going to have a problem. Not always. There are some rare cases. There are certain cases where this is in fact, I wouldn't say they're that rare, but if you're comparing numbers, they almost certainly are rare, where you will not be using, where using equals equals is a sign that you've done something wrong. But we will do one other thing here, which is there is the comparison that two things are equal, but sometimes we might want to compare if two things are not equal. So how do we write not equal? Well, the answer is the exclamation point. So in a lot of languages, the exclamation mark is related to saying the opposite or not of something. Something is not true. So there's two ways of doing this, and we'll just do them both real quick because I've got a little bit of time. So this is the same thing. This is saying if the count is not equals 9, print yay, else print nay. So now when we run it, you can say, oh, what did I do? Well, that's less than 30. we have a count of 7. Yay, that's a good thing. We have a count of 11. Yay, 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 yay. We have a count of 9, so we have a nay. So that's the opposite way around. And the one other way of writing this is, and it's probably best to put brackets around things, it's almost certainly best to put brackets, is that we can use that little exclamation mark again, but at the start. So this says, while not this thing, if not this thing, is a way of saying it, how to interpret this. So this thing is either true or false, and all that not is doing is it's changing the thing that follows it to be the opposite way around. So if this thing here evaluates to be true, then the not in the front of it will evaluate it to be false, and if it was true, it would become, if it was false, it would become true. So this is saying if not count equals 9, as opposed to saying if count not equals 9. And the reason I put brackets around that is I'm not too sure how the order of, like you have your BODMAS or whatever in maths. I'm not entirely sure how I've set up Glitter to do things in order. So what might happen if you didn't have those brackets, and we'll find out, what does it do? It gives an error, right? It says the app type int cannot have a not operator used on it. And the reason is the not thing is not knotting, as we say, this entire expression. It's trying to knot the count variable, and it can't do that because count is not a true or false thing, it's an integer value, and you can't say what is not for. Or you could, you can, if you're trying to be semantic, you might say, well, not for is anything that's not for. But in computer worlds, we don't have that kind of stuff. We don't have that kind of malarkey. So you have to put the brackets around it so that it's referring to this entire expression. So I hope that's probably the most complicated stuff. You're not going to write that this way. Not will come into things later on when we look at Boolean expressions, which is for another video, because this has been a fun, and that was my chair, that wasn't me farting. This has been a fun and exciting video as it was, and we had a few bugs that only one of them I showed, or two of them. But hopefully all those things will be fixed for the future versions. So thanks for watching. Next time, we are going to go over blocks or functions that we can make up to make our code do more exciting things. And the good thing about that is then we can make some pretty animated pictures. So the last two tutorials have been a little bit on the boring side when it comes to looks. But next time it's going to get pretty exciting. So thanks for watching, and bye.